Welcome back to the Foundry by Forge College. So you've hit deploy, the code is live on the Solana mainnet, and you're popping the champagne. But, right after that, the existential dread kind of sets in, right? Like, what happens the exact second after your application goes live? Well, today we are talking all about monitoring and compliance after deployment. We're literally turning your newly deployed app into a fully operational mission control. Because up until now, you've been entirely focused on building, testing, and just getting that code out there. But what happens the moment after it goes live? That's exactly what we're diving into today.
Following our last explainer on executing a staged deployment and release, your rocket is officially in orbit. Seriously, congratulations. But as literally any good engineer will tell you, just because it's up there doesn't mean it's functioning perfectly. We absolutely need telemetry to make sure it stays in orbit and operates smoothly. Think about it. If a thruster misfires, or, in our case, if a smart contract instruction starts failing, we need to know immediately, way before the users start complaining on Twitter.
So here's our engineering blueprint for today. We'll start with the launch aftermath. Look at the 3 layers of visibility. Build out the telemetry pipeline, define key metrics and alerts, put the canary in action, and finally, look at the debug report. Basically, we're building a diagnostic toolkit so we never have to fly blind. Let's get into it. Starting off with Section 1, the launch aftermath. Okay, so the crucial point here is that you've deployed the artifacts and you've run your basic smoke checks. But now we have to transition your mindset from building to operating. It's a completely different headspace, honestly. Immediate monitoring reveals how your app actually behaves in the wild. Real users do totally unexpected things, like trying to click submit 50 times a second. Network congestion happens. So we need to set up production-grade metrics, low noise alerts, and a compliance report. All of this operational evidence is going to feed directly into our final capstone optimization. We're moving from a reactive state to a highly proactive one. All right, moving right along to Section 2, 3 layers of visibility. To get full operational visibility, we can't just stare at one dashboard. It just doesn't work. We need to strategically place our sensors across 3 distinct layers. First, at the base, we have on-chain program telemetry. These are your structured instruction logs and account state observations pulling directly from the Solana blockchain. Second, we've got off-chain service telemetry. This covers the metrics from your RPC nodes and the API latency of your backend services. And third, synthetic transaction telemetry. Think of this almost like radar traffic, synthetic interactions that are pinging your app continuously at a controlled cadence just to measure baseline performance. Which brings us to Section 3, the telemetry pipeline. Now, what's really, really cool about this setup is how we wire all these disparate floating sensors together into a cohesive automated pipeline. First up, your synthetic scripts emit traces and metrics. Next, a collector, kind of think of it like a vacuum, like a Prometheus endpoint, scrapes this data from the RPC endpoints. Third, your dashboards combine all these metrics and logs into clean visual panels. And finally, alerts monitor those dashboard queries, totally ready to trigger if a specific rule is broken. So data flows beautifully from your test scripts, visualizes on a clean layout, and boom, automatically fires off alerts if things go sideways. Let's look at Section 4, Key Metrics and Alerts. So what exactly are these dashboards displaying, right? Well, this breaks down the really crucial signals. For instance, transaction latency tracks the end-to-end time for a transaction. That is vital for detecting backend slowness or RPC node congestion. Then we have instruction failure rate. If this spikes, it is a direct indicator that something in your program's actual logic is failing. And compute units per transaction? That's incredibly important on Solana. If the average compute units suddenly jump up, it signals hot code paths that are needlessly burning through resources and, silently draining your wallet in the process. Not good. Alongside all these metrics, we're also setting up what's called a compliance checkpoint. Now, hold on, don't let the word compliance put you to sleep. This isn't about boring legal red tape. It's about rigorous operational control. It's the immutable audit logs of who deployed what version at what exact time and snapshots of configuration limits. We collect all this data to create solid evidence that our systems are under control. It's a critical operational skill that you'll apply across other Forge College programs and, honestly, throughout your entire Web3 career. All right, now for the really fun part. Section 5, the canary in action. To actually test out our new mission control alarms, we are going to deploy a brave little bot called a canary transaction generator. Just like a canary in a coal mine, warning miners of danger, this synthetic, low-impact transaction is used to measure baseline behavior. It's basically a remarkably simple Node.js script that sends a transfer continuously. But because it sends 0 lamp ports, which is just the tiniest possible fraction of a sol, it doesn't actually cost us funds to run. But it perfectly mimics a real user, allowing us to accurately measure latency and catch errors in real time. It's brilliant. So here is the exact life cycle of our little canary. First, it connects to the network via the RPC URL. Second, it builds that 0 lamp port transfer, making absolute sure to sign and route it through the exact same program invocation paths a real user would take. Third, it runs a stopwatch to measure the end-to-end latency. And finally, if the transaction fails for any reason, it catches the error and ticks our counter up by 1. It just repeats this endlessly, creating a super reliable, reproducible signal. Next, we take that error counter and we hook it up to an alert. And this brilliantly illustrates the whole concept of low-noise alerting. We set a Prometheus rule to watch the error counter, triggering only when canary errors exceed 1 in a 5-minute window. Why the 5-minute window? Well, because brief network hiccups just happen, right? We want actionable alerts. We want an engineer to jump into action when there's a real fire, not waking up at 3 a.m. because of a tiny self-resolving false alarm. To prove this actually works, we trigger a controlled fire drill. We intentionally break the runner by giving it an invalid RPC URL. Almost immediately, our system catches the failure. The 5-minute threshold is crossed, and boom, this exact actionable message pops up for our on-call responder. Canary transactions are failing, check logs and recent deployments. I gotta tell you, it's incredibly satisfying to see your own safety nets catch a fall in real time. Finally, let's wrap things up with Section 6, the debug report. Once our controlled fire drill is over, all of this evidence gets packaged into a debug report. Think of this report as your official mission log. It's a time-stamped operational document that definitively proves your alerts actually work. But it doesn't just record the incident, right? It requires you to capture at least 2 prioritized remediation actions based on the metrics you observed. It perfectly bridges the gap between identifying a problem and planning the actual solution. This slide right here shows exactly what goes into that report. You'll grab pristine screenshots of your dashboards showing the latency and error spikes. You'll include the alert history from the system, showing the exact time the controlled test fired. And of course, you'll list those prioritized optimization actions. You're definitely going to want to commit all of these artifacts, your canary runner script, the YAML files that define your alert rules in plain text, and the debug report itself, directly into your project repository. And here is exactly why all of this hard work matters. This operational baseline tees up our final step, the capstone optimization. We've officially moved your mindset from I built it to I operate it. The rich data you are now collecting, the compute unit spikes, the latency hiccups, is exactly what we need for the next lesson. We're going to use this very telemetry to dive in and aggressively optimize the performance and cost of your Solana smart contracts. As we wrap up this explainer, I really want you to consider this question. What unseen bottlenecks will your new telemetry uncover when the real network load hits? Because now you actually have the tools to see them. Thank you so much for joining me for this explainer. Be sure to visit forge.college to learn more about this subject, dive into our optimization modules, and explore plenty of other fascinating Web3 topics. See you next time.